All right, my talk is titled, What Do We Mean by Mathematics? And this is a question I've been asking myself for a long time. And then when Amy and I co-edited a special issue in JMB, it came back up when we were talking about, what is the math that underlies society? Like, first we need to figure out what is math. And we happen to find ourselves in different ends of the spectrum quite a bit, and had some amazing discussions. So partially this came out of that, and partially it came out of me sitting in conferences, disagreeing vehemently, quietly on my inside with speakers, because I was like, well, how do you define math? I need to know that before I can engage with that. So first I want to say my work builds on the work of many others. And there's a few pictured here and stated. So this follows work by many others. And super honored to have Richard in the room, where I feel like my work hopefully is going towards the dialogic, which I've been starting to understand better over the last few years. So I'm very excited about that. All right, will you use your phones and just do a quick prediction? And the idea here is to predict. We're not expected to know, predict. What % of the Canadian population do you think is Jewish, Christian, or other? All right, so the numbers that I'm reading off here, and if you got the email, the prediction is for Jewish 11.6%, for Christian 37%, and for other 52%. So here's what it actually is. And one of the reasons I'm asking this is how I start most of my math classes, is we predict something to kind of see where we're at. And this is not to make fun of ourselves, it's to kind of adjust our worldview. We often have a skewed worldview because of where we live and what we do. So in the United States, I will often ask my students, how many, like if we shrink the world down to 100 people, how many do you think come from the United States? The answer is 4. The prediction is way higher than that, right? Because that's people's daily life. Similar here, right? Like our prediction was 11.6% and it's around 1%. Okay, and then Christian is always underestimated everywhere I go. It's always like 30s, and it's 53 here. It's, I think, a slightly bit higher in the United States. All right, so before moving on, I want to do an acknowledgement of harm then and now. And I rely on Elie Wiesel here, and quote from the book Night. And action is the only remedy to indifference, the most insidious danger of all. Human suffering anywhere concerns people everywhere. I replaced the men and women by people here because we're moved past the gender binary since then. Just to make clear that I didn't change the meaning of that. Okay, question for all of you. I'm going to give you 3 examples and I'm going to ask, are these mathematics? So here's a quote from Stamped. This is the youth version of How to Be an Anti-Racist by Ibrahim X. Kendi, which was huge in the US. I don't know if it was huge here too. And I was reading that with my daughter, and we read, today the United States remains nowhere close to racial equality. African Americans make up 40% of the incarcerated population. Is reading this mathematics? Here's another image of a mural close to where I live. Is that mathematics, engaging with that? And then here is a fact. And there's the estimated number of Jews killed in the Holocaust. And it's right around 6 million, depending on who we draw on. Okay. Now my thing doesn't work anymore.
Oh no, I just touched the thing.
That's okay.
Sorry.
Oh. Anyway, there's a talk and turn. Are any of these three mathematics? So if you're sitting by yourself, find somebody to sit with and have a conversation about whether you think any of these are mathematics, and if so, how. And I think Amy is going to read some of the online comments, so everybody in the room has access to them, and then we might share out a little bit.
Thank you. So some of the comments from online where it really depends on the who and the where, and the questions you ask. They can all be considered mathematics if you're asking and thinking critically about them. That's kind of a mix of comments from Stephen, Joyce, and Pam. Jimmy agrees. It depends on who we are, our circumstances, experiences, and roles. So extending that to think about context as well. And Stephen asked the question, is there any money, power, or prestige in addition to purpose attached to calling it mathematics? So some of the reasons behind why we might label it mathematics or not. But in the end, I think they say yes. They're mathematics, but it depends on who you ask. And then an opposing position from Howard. None are. They lack context. Numbers by themselves are not mathematics. Neither are figures, though they can be used to inform mathematics. Oh, and there are two Jimmys here. Hello, other Jimmys.
So does anybody in the room want to share what they were talking about? And you don't have to, just if you want to.
Can you describe what's in the painting? I don't.
Charles has just asked for a description of the painting.
So the painting is standing in for any mural you would see around any town. So just imagine it being a mural painted.
Our group had similar ideas to what came up in the chat, that it depends on interpretation, and interpretation depends on the interpreter, but also the context.
Anyone else? Okay, so let's move on. So I recently gave a similar presentation and realized that not everybody knows or remembers what the Holocaust is. So I'm just going to put one slide here to explain what that was. The Holocaust was the systematic murder of Europe's Jews by the Nazis and, and their collaborators during the Second World War. This program of targeted mass murder was a central part of the Nazis' broader plans to create a new world order based on their ideology. The Holocaust was the systematic state-sponsored persecution and murder of 6 million European Jews by Nazi German regime and its allies and collaborators. The Holocaust was an evolving process that took place throughout Europe between 1933 and 1945. So underlying assumptions to my talk, and I think it's always really important to explicate those. So I come to this talk with an understanding of the socio-historical and political context of slavery in the United States, white supremacy and anti-Blackness, anti-Semitism around the world, and immigrant communities in the United States. I chose those because I'm touching on some of those in my talk. The underlying assumption here mathematically is proportionality. The idea of fairness, and if things were equal for all, then the prison population would reflect the population at large. The population in an honors math class and a remedial algebra class would look the same, and the rate of Jewish people before the Holocaust and today would be the same. Okay, so why ask the question, what do we mean by mathematics? Because we want to avoid frustration. What do we mean by mathematics? Some people think 2 + 2 is 4, and those kinds of things constitute mathematics. And other people think that statements like Black kids are overrepresented in remedial math classes represent mathematics. So what happens is I was interviewed on a local television show about anti-bias mathematics. And one of the first questions you always get, well, is 2 + 2 still 4? Like, it depends. 2 + 2 is 4, like, without context. And 2 cats and 2 dogs are 4 animals, but they're not 4 cats, and they're also not 4 dogs. So it's not as easy. So people who believe that math is this abstract collection of facts often ask, well, where's the math? And people who take a different view are often frustrated because they're like, it's right here. So we've been here before in the mathematics education community. In about 2010, JRME, which is the premier journal in mathematics education in the United States, asked the question, where's the math? The then editor, Kathy Hyde, stated, JRME publishes research in which mathematics is an essential component rather than being a backdrop for another area of inquiry. And Gershon Harel worried that current papers are adventitious. I don't even know how to say it. I didn't know what it means. I had to look it up. It means supplemental, not inherent to mathematics. On the other side of this argument, Danny Martin and Foote and Bartel raised the question, whose mathematics are we referring to, and who gets to decide what is and isn't mathematics in MathEd research? And then went on to talk about issues of identity, language, power, racialization, and socialization were often left out of mathematics education research, and wondered why contributing to equitable math experience and outcomes should not be part of mathematics education. So Wagner described the significant divide between scholars who attend to the sociocultural aspects and those who do not. So that was 2010, and we're back kind of in the same back and forth. So why am I talking about this? There's a paper that my colleagues and I published in JRME that was a big outcome paper of multiple grants, and it was called The Efficacy of Research-Based Mathematics for All Professional Development. And in this paper, we studied the professional development that was implemented in like a large school district, and we had people who implemented it and people who didn't, and we looked at, did it make a difference? And we found, hey, yeah, it makes a slight difference. Awesome, good job. And then we disaggregated the data. And what we found is that there was actually inequitable achievements for students once we disaggregated the data. And we can see in this graphic that it was the Black and Latino students who actually did slightly worse. You don't have to be able to read the graphic. So had we not disaggregated the data, our report would have been like, this is a great professional development. But because we disaggregated and looked at it, we were like, well, it's good for some and not for others. All right, positioning myself, and apologies to those who were in my talk yesterday. I'm still the same person. So this is myself, Eva Thanheiser. I use she, her pronouns. And my identity is heavily drawn upon my history. I grew up with a foreign single mother who is Jewish in Germany, the country that murdered my grandmother and incarcerated the rest of my family in the Holocaust. There were very few Jews left in Germany. I knew nobody like me. I am now German and Jewish immigrant in the United States and still don't really know anyone like me. And so we're like one of those wandering families. So you see my mother's youth, 40s to 60s in Hungary, my youth, 70s to 90s. Dang, we're getting old. Germany. And then I live in the United States now with my 3 daughters and my husband, and my mother and my sister and my niece live in Israel currently. So there's an image of my daughters and myself, and there's an image of my sister, my mother, and myself. Those are my languages that I've learned. Hungarian was my first, German my second, English my third, and French I learned in school. English I learned in school too, but now I'm speaking English much better than I learned in school. And this is another part of my identity, my work identity. If you look at my work life, I'm the only woman tenured faculty member in my department, and also one of very few math educators. And finally, this is my history. I have a master's in mathematics and a PhD in math education. I was always successful in math, and with successful, I mean I was able to find the answers in school. And then I always figured out why, and I thought that everybody does that. It was way later that I realized not everybody was trying to figure out why. But I struggled almost with every other subject in school to the point where people didn't think I would be able to finish high school, never mind move further. I'm now a professor in the math department and the only tenured woman. In my research history, when I did my PhD, I focused on place value and content for several years. Then I moved to motivation, and just recently I've moved into the critical math education. So these three frames are also a little bit a trace of my own history in how I came to define mathematics. And I'm drawing on the Aguirre et al.'s Teaching Math with Social Justice framework, which starts with a broad social issue, has a specific situation, and then this is a piece that I am asking, and I'm going to argue that this is mathematics, is asking questions. And then there's the mathematical make sense of the situation, research the information needed, and have your assumptions, compute a solution, interpret the solution, validate the outcome, and then report back out, and then build civic awareness and keep going in these circles as needed. So that's the model I'm using. Now, like, what is math? I'm also using framing. Framing, I've started reading up on it and really helped me make sense of it. And this is based on George Lakoff's work. And if you have not read this book, I highly recommend it. It's really set in political context and explains why in the United States, at least, we're not able to talk to each other. But I'm going to use it for math and for elephant right now. If I say the word elephant, what are you all imagining? What comes to your mind? Be more specific. Big gray animal. Big ears. Okay. So large animal, large floppy ears, trunk that functions like both a nose and a hand, large stump-like legs, and so on. That would be a frame for an elephant. But many things could be what the picture is, right? But there's like one frame and all of them have kind of the same thing together. But then there's words that have more than one frame. So if I say picture, what comes to mind? Like something you pour water out of, or a baseball player, right? So there's two different things that can come to mind. And this is how I'm thinking about mathematics too. Like there's different things that can come to mind, and they might all be true at the same time, but they might be really different. All right, so frames are mental structures that shape the way we see the world. Every word comes with one or more frames, and most frames are unconscious and have just developed naturally and haphazardly and have come into the public's mind through common use. So again, remember that what is math? So here's my first frame of mathematics. Mathematics as an abstract body of knowledge, the organization of that into systems and structures, and a set of methods for reaching conclusions. In the United States, we have something called the Common Core Standards, which are standards that everybody's supposed to adhere to for different grade levels. I'm sure you have something similar. Okay. So I'm pulling a 6th grade standard here. Use ratio and rate reasoning to solve real world and mathematical problems by reasoning about tables, equivalent ratios, make tables of equivalent ratios relating quantities and whole number measurements and so forth, find percent of a quantity and so forth. So that would be like an abstract mathematical representation. Then there's also modeling with mathematics. Apply the mathematics they know to solve problems arising in everyday life and society. And then there is the cultivating positive math identities. Recognize that their roles are due to cultivate positive mathematical identities in their students. So here's a math problem that I'm going to give you a minute to solve. And in the online, you guys take a minute and then put something in the chat. The question is, find a ratio percentage of 16 million green items in a collection of 2 billion items. Now you have 8 billion items with the same ratio of green to total items. How many of those would be green? You may use calculators if you like. Anyone have a solution? You guys have a solution? What's your solution? Yeah.
So the question mark one should be 64 million, because we are proportional, we multiply by 4. And the percent of green items should be 8 over 1,000, which I think is 1 over 125, which is like 0.01, something less than 1.
Yeah.
Okay. And the same thing for the one below it.
And online agrees. How about the rest of you? Yes? Okay. So this is a typical math problem that we might solve. The numbers are a little bit big. That's because I want to go to a specific context. But we have a ×4 relationship. So we have the 64 million. And then we have 16 million and 2 billion. That is 16 in 2,000. That is 8 in 1,000. That is 0.8%, right?
Okay, can I add, before we started, we had like maybe a cultural difference of what do we mean by billion?
Yes.
Like what number is billion? So we had to
Yes.
clarify or decide what we meant by that first.
Agreed, because in Germany, the term is also different than in the United States. And I'm not in the United States, remember? So what's a billion here? Same as in the, but in French it's different. In German it's different too. We have like a different thing for that called Milliarde, and then a billion has another, it's like the next one up. Yeah. So I usually address that. I forgot that I need to address that. Yes, thank you for pointing that out. All right, so here's our math problem for an English-speaking audience. All right, frame 2. Mathematics as contextual, ever-present as a lens or language to make sense of the world. And I'll go more into what each of these frames mean. And then the frame 3 is mathematics as a verb, something we do, not something that exists. A human activity, part of one's identity. So again, coming back to this problem, in frame 1, find a ratio percentage of 16 million green items in a collection of 2 billion items. Now you have 8 billion items, the same ratio of green to total. How many of these would be green? We solved that. Now I'm going to change the problem. We know that when the world had 2 billion people in it, 16 million of them were Jewish. What is the rate or percentage of the Jewish population? Assuming that the rate or percentage stays the same, how many Jewish people are in the world today when there are 8 billion people? Same context, same math, but put a context. Now I'm going to push the context just a little bit further. In 1939, right as the mass extinction of Jews in Europe took full force, we know that the world had 2 billion people in it, 16 million of them were Jewish. What is the rate percentage of the Jewish population? Without the Holocaust, assuming the rate stays the same, how many Jewish people are in the world today when there are 8 billion people? So we have this broad social issue, we have a specific situation, and we ask questions. For this fact of there are 6 million Jews murdered in the Holocaust, I just gave a talk somewhere else where I dug into all of these questions. Today, I'm only going to dig into the last one. How many people would be alive today if the Holocaust had not happened? So here's my question. I'm doing the mathematics. And there's a headline in 2015 that said, has the global Jewish population finally rebounded from the Holocaust? Not exactly. So we see that we're currently in a state where we almost have as many Jewish people in the world as we did before the Holocaust. So what it was, year 1939, world population 2 billion, Jewish population 16 million. What it is, 2024, world population 18 billion, Jewish population 16 million, 2 in 1,000. What it should be, had we not murdered all those people, would be 64 million. So we are missing 48 million Jewish people. And to tie this to my own personal history, oh, sorry, here, it's a different representation. So this is what we have. World population is 8 billion or 2 billion. The Jewish population is right around 16 million. And here's what it should be, and here are the people who are missing. My family. The picture you see is my grandmother, who was deported right after my mother was born and murdered in the concentration camps. Then you see myself, where it says me and my 3 beautiful daughters on the bottom, and my sister and her 1 daughter. This is us defying the extermination. But what you don't see is potential siblings my mother could have had and potential cousins for myself and my children. So there's the stolen families that never got to exist because of the mass murder of Jews. So reporting out, building some awareness. Coming back to the frames of mathematics. I was just talking about the fact here on the bottom, how many Jews were killed. And if you look at that for myself, this is an identity piece for myself. Like, what does math mean? This is frame 3. It helps me understand my own identity. And interestingly, I dug into this after I wrote the frames paper, because I was like, I now want to see how I can use math to help me make sense of my own identity. But for other people who don't have that history, this might be frame 2, where they're learning about the world. So it depends on who you are, what this is going to be. So let's go to the quote I showed at the beginning. Today, the United States remains nowhere close to racial equality. African Americans make up 40% of the incarcerated population. I'm going to use the exact same mathematics here. Asking the question, what does it really mean? Today, the United States remains nowhere close to racial equality. Does this mean it's proportional? If not, how disproportionate is it? To me, asking these questions is mathematics. Reading a sentence and critically questioning it. So we go into the math. We look up the US Census and the Sentencing Project, and we get our numbers. In the United States, the population currently is 13% identifies as Black. And you notice that it said African Americans earlier. It says Black now because we're using whatever the sources have that we use. So the census uses Black now and not Hispanic. So there's a Black and Hispanic and a Black and not Hispanic. And then 60% of the US population identifies as white and not Hispanic. So that's the census. The sentencing project shows that the incarcerated population per 100,000. So they're not giving us percents, not an easy comparison, but it's 1,240 per 100,000 is the rate of Black prisoners, and 261 is the rate of white prisoners. We can already see that this is incredibly unfair. But how unfair is it actually? So if we adjust the rate to reflect the population, the 1,240 should be equivalent to 13% of the prison population, which then means we need to figure out what 60% is, right? So if 1,240 is 13%, then dividing that by 13 is 1%, so 95 is 1%. Multiply that by 60, we get 60%. 5,700 is what 60% should be. Again, a Common Core standard, use proportional relationships to solve multi-step ratio and percent problems. Thus, for each 1,240 Black prisoners, there should be 5,700 white prisoners. And if we look at this, we see there are 261. So if we compare those numbers, we see that there is almost 22 times you're more likely to be imprisoned if you're Black than if you're white. Now that's a huge number, which doesn't come out in a sentence that says 40% of the prison population is Black, because we think, oh, well, 13%, so it's, you know, like, but it doesn't show the severity of how unfair it is. Okay, so the fact that Black people are incarcerated at such a higher rate is based on a racist, white supremacist system that over-polices and underprivileges this community. Again, this is important that we make sure we understand why this is, that this isn't for any other reason than white supremacy and evil political design. So let me come back to my frames of math. Mathematics as an abstract body of knowledge, ideas, the organization of that into systems and structures, and a set of methods for reaching conclusions. So going on a little bit more into this, what does this mean? It's a science of patterns. It's an intellectual activity which calls for both intuition and imagination in deriving proofs and reaching conclusions. It's justification and generalization, which are often seen as the ultimate goal to achieve in K-12 mathematics classrooms. The National Research Council has defined mathematics as conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition. In the United States, school mathematics is still typically defined as a discrete set of topics taught in linear progression that ultimately leads to calculus. This is the only version of mathematics that most people know, and thus calculus is seen as the pinnacle of math understanding. Understandably, people want their kids to do calculus, because if you do calculus, you're smart and you're more successful potentially in college. So it's one of these barriers that we put into place. Okay, frame 2, what does that actually mean? Mathematics as contextual, ever present as a lens to see the world. I draw a lot on Karim Ani's book here, and again, another amazing book to read. That's called Dear Citizen Math, where he defines math as a tool to think about questions we confront as a society, a tool for exploring questions about real life, a lens for viewing reality, and a prism for looking at the world, for analyzing how it works and reimagining how it could work. Mathematics is a tool that we humans have invented to explore the world around us and think more creatively about it. Math is a way of thinking, and I very much sympathize with that. And then critical mathematics educators often define mathematics as contextual and inseparable from context. And I'm not going to go into reading this. So let's go into frame 3. Frame 3, we're moving now. Mathematics is not removed from humans out there to be discovered, but is a human practice. It's a practice of living beings. And so first of all, we need to refine it from being a noun to being a verb. And this is something really important, because if it's something we do, then as students, we can actually engage with it, create it, and become owners of it. If it's only something that we learn, that's out there already, we have a very different relationship to it. So mathematics goes from being a noun, a stable thing, and something that exists, towards mathematics as a verb, a thing that is created and enacted by humans. Students, as the authors of their own mathematical understanding, and as such, mathematics becomes inextricably linked to one's identity. So the identity piece, and I draw a lot on impact of identity in K-8 mathematics by Aguirre and all, and a brand new version for K-12 mathematics has just been released. I haven't read the new version yet, but I'm excited for it. They argue that students need to learn mathematics in light of who they are and the diverse gifts they bring to their experiences in every day. So math needs to connect to who we are and what we are. mathematical identity is often defined as how we see ourselves as mathematical doers. And I want to say that to me, that again relies on how do we define mathematics. And so I just broadened it to identity in general, help you make sense of yourself. So here, Martin defines, that's Danny Martin, defines math identity as the dispositions and deeply held beliefs that individuals develop within their overall self-concept about their ability to participate and perform effectively in mathematics contexts and to use mathematics to change the conditions of their lives. If we take on the assumptions that mathematics is part of who we are and how we look at the world, then how we are perceived and whether we're given access to sense-making is inextricably linked to mathematics teaching and learning. Thus, the question of where is math as such is very frustrating in this frame 3, because we understood that the teaching and learning of math has always depended on issues that, although not directly focused on content, deeply affected how content was taught and who receives access to it. So, what is student-centered math? I think you've gathered by now that I'm a very big proponent of student-centered math. So in a different paper, a colleague of mine and I defined student-centered math as having these 3 components. Students' mathematical thinking is being made public, so people can engage with it. Students engaging with each other's mathematical thinking, and students' mathematical sense-making, conjecturing, and justifying drives instruction. That's how we imagine mathematics classrooms to look like. So then if we go to frame 2, what does that mean? So instead of just mathematical, we're now going to include students' general thinking being made public. That is mathematical and political, social, etc. And students engage with each other, again, broader, mathematical, politically, social. And students' sense-making with respect to all of those drives instruction. So that would be frame 2. And in frame 3, it's really who students are that drives instruction. So I'm going to understand who are the students in my classroom and try to learn from them and with them what is interesting to them, what do they want to learn about, and then contextualize the mathematics I want to teach them in those contexts. So currently, I have a grad student who is looking at who wrote a paper where we asked the students, what are you interested in learning about the world? Because it was about the world. And most of them put in health and I think education. So after looking at what the most of them said, those were the contexts we picked to kind of dig into some of the mathematics. And so what I want to say is Bob Moses used to say algebra is a civil rights issue. And Robert Berry, who was most recently the president of the National Council of Teachers of Mathematics, has broadened this to mathematical literacy is a civil rights issue. And I also believe that access to mathematical thinking and understanding the world and understanding yourselves is a civil rights issue. And with that, I'm going to close out my part.